you give, making sure that things work here. Also, Susan is very busy over there and will help when there's a problem with me or whatever. So, which is good. Welcome to Antarctica. Why don't we find someplace warm? Why are we talking about Antarctica? Out there, and it's a whole lot warmer here than there, that's for sure. Okay. Just a moment. I'm not sure that your map shows all of this, but on this particular map, if you can see the little red dots around the edge and all over it, those are research stations. So obviously there are quite a few, if you can count all the red dots. And we'll look at some of these. That's one of the main reasons why we are over there in Antarctica, is for research. Not much else can happen over there unless you want to think tourism is a big trade, and that's a little bit iffy too. But people do go and visit there on tours and the like. Well, we're looking at this particular one so that we see what the whole continent happens to be, and see whether you remember this from your education somewhere way back. It's to be the South Pole, and we'll visit that a number of times. The South Pole. And if you take a look at the edges here, you can see something called the Southern Ocean. And we'll look at that again in another more distinctive way. But the Southern Ocean is one of the largest oceans on the Earth. And usually you don't think about that one, but it is there. And of course, it butts up against the other major oceans of the world. So all of them except the Antarctic or the Arctic one. So, okay. French claim, New Zealand claim, and the like, all the way around. Is absent on this particular one is something called the U.S. claim. And the only thing that we really have in the United States, particularly that they can divide up as far as claim, happens to be at McMurdo, which we'll see in just a little bit. That's over here on the Ross ice sheet. So in the Ross Sea, okay. Receding ice is receding on one part and breaking away. We'll see some examples of that, and gradually having a little bit of a problem, but it is expanding on the other side. So there seems to be movement in one direction here. Some is growing less and some is expanding again. All right, the contribution of the ice melt to the global sea level. Notice that the Antarctic does contribute to quite a bit, but Greenland does more. And if you put the two together, this is how much of the upping of the sea level that's occurring. And we're very much involved with this problem of too much water in the oceans. How can that be? But it's there. Has to take place. And you remember last time we talked about the Arctic Treaty. Well, that's a whole bunch of people or countries were in that. Now let's take a look at the Antarctic Treaty and see who's involved here. That's quite different in some ways because territory, well, you're not a half, you can't own it. No country can own it. Errors in Argentina. countries meet annually ever since 2004. South Africa, Russia, UK, British, and USA. So there is a somewhat of a governance system, if you will. In treaty, basically, I get rid of that. Okay. Emphasize here on this last part, which was being covered, is no military, none, no weapons testing, nothing on that order. They've all agreed to keep that out of there, we think anyway. These here that are actually cooperating with each other when they, especially if there's a problem, and there's problems of people getting lost or getting in trouble because of the cold. So, okay, help each other, whether it's whatever country you happen to be from. It's decided to permit Russia to dispose of its waste at the shoreline in the Belgian station. And this is an example of where they were just dumping their stuff. So keep it pure over there in the Antarctic. The tour's flags of the 12 nations are shown here. These are in the inner circle here, as you can see, and the other ones are involved somehow. And they get along. 33 countries were added to the 12 that have what they call acceding state status. So they do have some involvement with the original ones. Or object of international discord. That's quite a very kind of interesting statement. Susan.
He's going to swap out.
Part here for a moment. Okay. Work on your quiz over at home if you can get the answers. Does that stay? No, there goes away. Okay, all right. All right, we'll proceed some more, and then if it has a problem while you're still here, that's okay. At any rate, they do not want international discord over here. This treaty applies to an area south of the 60 degrees south latitude, pretty well south of the Antarctic Circle. It has been in force since June of 1961. It has been really quite successful in this whole adventure. Consultative meetings are held annually. In December 3 of 2009, meeting was at the Smithsonian Institution in Washington, D.C. But it's also elsewhere, as you can soon find out. They are rotated annually, these meetings, between member nations. Next, and the meeting today is, or at this particular time, is still with the last meeting place, which happens to be in Paris. So, once again, look at all the dots. 60 research stations are shown here. And as you can see, most of them are around the edge. Only a couple in the interior. And then, of course, right in this area here, we have the South Pole, and that's of real interest to us today, or to me anyway. We'll see once what happens there. But the red ones are permanent stations. And the yellow ones, in this case, are summer locations. So there are a couple here that are simply not named and temporary kinds of stations. But they are there's a lot of interest from a lot of countries in what's going on here at this particular continent. So that's part of it. Countries with the most research stations, let me list them down. Russia has 8, Argentina 6, Chile has 5, United States 4. We don't have that many, but we have a couple of very important ones. Japan has 3, Australia has 3. India has 3, so there are many involved here. Germany has 3. Once again, you see this area and it's spread into triangles. And if you look around the edge, you know, we can't say they own in the territory, but they claim it as their area that they work in. So you have around the circle, if you will. If I could show them at all. The major ones are the Australian, I think, maybe is the largest as any, partly because there's an important research center and in that area, but New Zealand also has a rather important claim area. They have the, what should I say, kind of a headquarters, if you will, in New Zealand, in its relationship to all of Antarctica in Christchurch. And that we'll see pretty soon too. So the claims are from various people. As you can see, Argentina is involved, Chile is involved, and various other countries. If you look at this, you can see that there is 1 sunrise per year, 1 sunset per year. Otherwise, it's dark in half of the year and it's light the other half. If you can think about 1 sunset and 1 sunrise in a whole year's time. So once it's up and it stays up for a half a year. Okay. I mentioned some of these areas. Ice shelves seem to be as important as the main center. In fact, there's happens to be the Wilkins ice shelf. Notice this peninsula that sort of sticks out toward Argentina. Look at that. The Widell Sea has a big glacier that keeps on calving off into its sea. The Ross Sea is where the United States is interested. And we'll see in a little bit that, and you can check on your map too, that right in this point at Ross Sea is McMurdo. And McMurdo is the place where the United States does almost all of its work, as well as at the South Pole. But so if you see where the Ross Sea is and the South Pole, how close they are to to each other at that point. Well, they're not very close at all. All right, one of these that we're looking at is the Larson ice shelf on the Antarctic Peninsula. So it just continues to calve off at that particular one. But it's way on the peninsula rather than the main part of Argentina. And then there's another ice shelf that broke off at Thwaites Glacier, about 87 miles from Thwaites, blocking 2 research vessels at this particular picture. So that particular ice shelf, it keeps breaking off and floating out, all right? Thwaites is a big glacier, and we'll show that in a moment. But take a look at the various glaciers that are around it. Now, the main one here is Thwaites, and this is one of the breakoffs, the Dodson one. Again, this particular glacier is known as the Doomsday Glacier. They figure that if Thwaites collapses in 3 years, it could raise sea level 2 feet, which is quite disastrous to a number of communities in the world. This business of having too high increase, it will affect the United States in several places, at least somewhat, like in Florida. But there's some islands out in the Indian Ocean, the Maldives, for instance. They are no more than, on average, 6 feet above sea level. So what are you going to do if you start raising the sea level? They are really in trouble. That is one little country that is very important in learning more and influencing other countries about global warming. Their very life depends on it. Once again, we'll take a look at where that Thwaites Glacier happens to be. Notice where it's not here by the Ross, but it is up here. And in that little clearing area of the Antarctic continent. Looking at that particular one to see where it's starting to break off. This particular one, this glacier is gradually breaking, and where it says TEIS, and on the other side, the propagating rifts, there are weak areas in that glacier, and each time they get some movement going on, some of this breaks off. Take a look at where that glacier happens to be in the Antarctic. And notice that, well, if you project it out, there's a comparison here to the United Kingdom. If you can see that, it's not too different in size as to the England and Scotland or Ireland. Here's kind of a diagram of what happens on the edge of the glaciers as they get into the ocean, into the Southern Ocean. And it's eventually, the closer it gets to the water itself, it starts to form crevasses, and then eventually it will break off, and then the calving occurs, and it starts to float out into the sea. And then you get the sea ice, which is kind of a mushy kind of thing that floats out into the ocean and disappears eventually into the regular ocean water. There are 2 different currents in this particular. You got a warm circumpolar current that comes underneath to do the melting, and then of course it pushes it on out. And we'll see that circumpolar stream again in another slide here for a minute. Here's another glacier, the Taylor Glacier, which is more recently, it seems to be more recently active. This happens to be a pretty long one, 34 miles long, and it feeds Lake Fraywell in Victoria Land, and it has a rather interesting color to it, blue ice being formed in this case in that lake. a diagram of the Widell Sea. Notice this big chunk has been broken off of that glacier into the Widell Sea. And that, of course, is going to make quite a bit of difference. It is off the Rhone ice shelf in the Widell Sea. That's what we see here. Here is the Widell Sea, and that is that big ice sheet where this is being broken off. That's on the other side. Remember that McMurdo is down here at the Ross Sea. And that's where the United States does much of its work. Again, the Arctic Circle, Antarctic Circle, it pretty well covers the continent itself. So it's hardly any of the continent of Antarctica sticks out of that circle. A little picture of Mount Sidley. Notice how they work on underneath in the mantle, produces its own volcano and pushes up constantly in this chunk of ice over at Mount Sidley. Here's another picture of Airbus. It's called ginormous. The term meaning it's really very large and the like, and it's the most active one in the area at this point. This last eruption was 2015. It's the second highest mountain after Mount Sidley. It exploded during this last eruption. Rock examples at 1.3 million years old. So it just exploded out of the top of it and on the area. Well, I don't know about this, about penguins. Just toss this in here to see whether it's making any sense. You guys see here, I don't know what jersey you're wearing there, mate, but be advised that we're in New Zealand, Antarctic territory. So little spoof on all these penguins that are supposed to be around here. Yeah, this is kind of interesting. What do you think about? Are these all penguins? What do you think? They're the babies. They're the babies. They have this nice warm fur coat on, so to speak. It will molt off eventually, and then you wind up with this nice white one. Okay. We'll look at a couple of them once again, to fix in your mind. The Queen Maud Land is one of them. The Murray Byrd Land is another. Victoria Land. We'll look at some of these as we go along here, and we see where some of these explorers wound up. We'll start off with Graham Land. See where it is in this corner. That's a British claim. James Graham gave it the name, 1832. Marie Byrd Land was given by Admiral Byrd. That's the name of his wife. See where, okay. And then there's Victoria Land. And then, of course, we've got something called James C. Ross, who gave the name to the Ross Sea in Victoria. So names seem to be coming from the British here pretty well for the local areas. The Wilkes Land, USA, Australia claimed first. And that was by Lieutenant Wilkes. He went up into the Queen Maud Land. And then King Haakon The 7th came along and from Norway, and also in that Queen Maud, Wales area. And then you have a couple of others here. South Orkney are part of the Falkland Islands. Now, we pretty well are set up to see what's happening. We'll look at Arctic explorers and see where they go. James Cook was a rather important one, and notice his dates. And we'll see a number of these, so we'll try to come back to see what each one did in order to explore the Antarctic. James Clark Ross gave the name to the one ice sheet. And Robert Scott, we'll look at him. Ernest Shackleton. Roland Amundsen. Richard Byrd. Most of you probably remember him somewhat. Ralph Finesse. He, by the way, is still living, so there's no date on him. Let's start with James Cook. He explored much of the Pacific Ocean, including Australia, New Zealand, and the Hawaiian Islands, where he lost his life. That's James Cook. He crossed the Antarctic Circle back in 1773. He was 75 miles from the southern continent when he ran into ice. He wintered in New Zealand. He sailed around the Southern Ocean the next spring. And take a look at the green trail that he made. And that actually, of course, is all the way around the Antarctic, which is way here on the bottom of the map, as you can see. So the green the green trail here does show how he went around the entire continent. Then the guy by the name of Ross came along. At least he gave his name to one of the main ice sheet. He was a British explorer that traveled to both Arctic and Antarctic. And there's a dip circle in the corner here, if you can take a look at that. Anybody heard of a dip circle before? What do you think it looks like? Well, it happens to be some kind of a compass. It was used to measure the angle between the horizon and the Earth's magnetic field. It had 3 needles, 2 to point north and 1 to point to a strong magnetic field, whatever that happens to be. Now, if you traveled with a dip circle before the other compasses came about, these people would notice that the major needle in the circle, if you were in the northern hemisphere, actually, if you were on the North Pole, it would be dipping straight down. If you were halfway to the North Pole in the northern hemisphere, it would be about halfway down at a 45-degree angle. And if you were on the equator, it would be absolutely level. So you get into the southern hemisphere, and of course, now what? It actually dipped up rather than down as you get to the magnetic fields toward the south. So it was very imprecise, but it did at least help the navigators somewhat as they moved around. That was the dip circle. And it kept moving around partly because of this problem. The core, made of nickel and iron, rotates faster inside the Earth than the Earth itself. So you've got a little bit of a problem there. It takes 400 years to catch up. Ross charted much of the Antarctic coast in 1841. He discovered the Ross Sea, the Victoria Land area, Mount Erebus, and then the Mount Terror and the Ross Ice Shelf. He took 2 ships, the Erebus and the Terror, that were lost in the Arctic ice later. These 2 ships were called bomb vessels because They were built with heavy, strong hulls to withstand the recoil of mortar shells for the war that they were in. So they were good for ice breakers. They could bust into the ice, at least go in somewhat in these seas area. So then the Ross Island has three small volcanoes. The Mount Byrd, Mount Terror, and Mount Erebus are Mount Erebus is the active volcano. The others are dormant at this particular point. So there's action all the time. If you look on the surface, you can see Mount Erebus in the distance. And of course, we saw that a moment ago. It shows to you again. Okay, where are we? Well, we looked at James Clark Austin. Robert Scott, what about him? That's the next one to look at before we get to the rest of these. Well, he took off from the Ross Sea area, and you will notice that there are a couple of different lines here. Scott is this little dippy green line at that particular point because he never made it. And we'll see what happened to him at that point. And then there's Shackleton, and then Roland Amundsen in the blue, and Robert Scott also did actually make it up one time in the other blue. Let's look at him and see what he tried to do. His first attempt to reach the South Pole was a disaster. His dogs died from bad food, and the wind-driven snow forced him to return to McMurdo. He had come to about 480 miles from the pole, so he never made it. There's once again a picture of where he had to come from, McMurdo. Scott was a British explorer who reached the South Pole in 34 days after Amundsen in 1912. Scott had disastrous results using dogs on his first attempt to the South Pole. What do you think he tried to do? Well, he thought maybe ponies might work. So he got some ponies. He used ponies because the motor sledge was still in the experimental stage. So he thought, well, let's use these ponies to work. Getting ponies ready here in New Zealand and in this particular picture. Well, Scott loaded the ship in New Zealand, 24 dogs, 19 Siberian ponies, 3 motorized sledges. During a storm, 2 ponies, a dog, and 10 tons of coal and 65 gallons of petrol were lost, and the ship was stuck in the ice for 20 days. They had a real problem trying to get through into the North Pole or South Pole. The ponies here are shown aboard the Terra Nova ship. In order for them to be able to walk in the ice, these are the shoes that they put on the ponies' feet. Now, here is a little contest that's being made, and it'll come through again pretty soon. But notice that people over here in the Ross Shelf, one of them is traveling from this point at the Bay of Whales, and the other over on this side of the Ross Island. Scott was over on the left here, and Amundsen was on the other. We'll see again that picture in just a little bit, but notice that Scott and the 4 men died from exhaustion, hunger, and extreme cold returning from the pole. And here they returned from the pole. One of them died at this point, one of his members, Evans, and another greatest at this point, and later Scott and the others died at this point. So they never did make it back to the original camp at that point. Then there was this controversy, discussion anyway. What's better to keep the cold out? Do you wear wool or do you wear down? Down, you could keep the cold out better with down. On the other hand, if you had wool, your wool jackets might breathe a little bit, so to speak, so that if you wore down and you sweated all because you were walking a lot, it would really turn very cold when this was exposed. Whereas the wool seemed to be able to withstand some of that, and so it was really warmer. So, well, let's see once what Shackleton had to say. He traveled also into the research area. He was a third officer on Scott's first attempt to the South Pole. He established a new record for farthest south latitude, and it is 88 degrees, out to 90. He died before he made his goal to cross the Antarctic continent. He wanted to go straight across the South Pole and get to the other side. Never made it. So he intended to cross all the way in 1800, or the 1800 miles, but he never made it. When he got over there to his ship again, because he had to abort, the ship Endurance was crushed in the Widell Sea. Ernest Shackleton's vessel Endurance, a 140-foot wooden ship, lost off the coast of the Antarctica in 1915. All right, he took long boats with all the supplies, made it to Elephant Island, right up here. And then he survived on blubber and made it, at least for a while. Now we move on to Edmondson. No, not Mawson. Okay, what did he do? An Australian assigned to find the magnetic South Pole. Where was that anyway? He started with 5 men, but he and 2 others continued on toward the pole. 1 man died of bad food, the other fell into a crevasse. Mawson also fell into a crevasse, but the sledge wedged so he could be pulled out. Very dangerous. Then you have these people, this person, Amundsen, who made quite a splash as far as being the first person to reach both North and South poles. Here he is at the South Pole. He arrived with his dogs and made it just fine. Again, we see this same little V that I showed you before, and you will see where the problems were for Scott. If you take a look at this one, these 2 trails, Amundsen made it all the way to the South Pole, whereas Shackleton did not. So he's up to that point. Amundsen landed first on the Ross Island ice sheet. He called this Camp Framheim after his ship named the Fram. This was located at the Bay of Whales, 60 miles closer to the South Pole than McMurdo. The ice sheet broke away in 2000, carrying the campsite with it, so it's gone. Amundsen's first attempt was too stormy and he turned back. In the second attempt, he took 4 sledges and 52 dogs. He wore Eskimo-style skin clothes rather than the wools. He arrived at the South Pole December 14, 1911. He returned to base with 11 dogs. So he made, out of the 52, he lost quite a few in order to, only 11 survived. Then you get Byrd. He's probably the most famous one. Byrd had 2 ships and 3 airplanes. He flew the Floyd Bennett to the South Pole and back again to his base on the Ross Ice Shelf, and had to do that in 18 hours and 41 minutes. Way back in the 1928. Admiral Byrd spent 5 months alone at an advanced base to record meteorological data. He became weak due to carbon monoxide from a poorly vented heater. So it took 3 tries for a doctor and 2 men to rescue him. There's his plane. He took 2 ships and a 3 Ford tri-motor airplane to Little America, created on the ice sheet. In 1929, he flew to the South Pole and back. There's the statue over in the area of the South Pole. He had to dump some of his supplies to lighten his load so he could gain enough altitude to fly over the polar plateau. And then we got another guy. His name was Ralph Finesse. And as you can see, he had a little problem with his fingers. The British holder of several endurance records. The first man to visit North and South Poles by surface means. He had a heart attack June 3, 2009, but before he did that, he climbed Mount Everest before he had the heart attack. Here was a problem. Take a look at where the South Pole is, but notice that the magnetic pole is way off, way on this end, and it keeps moving around. So as far as the ice is concerned. This picture shows you the Southern Ocean. And the arrows along the Southern Ocean here, there are easterly winds and currents right next to Antarctica, whereas there are westerly winds just a bit to the north of that. So you have counter surges, one going one way and the other going the other way here in the Southern Ocean. And that is true on this basic map of all the winds that you see. The easters are way here on the land in that part of Antarctica, and the westerlies are coming in from the other side. Again, all the currents of the ocean here run into land except the west wind drift around Antarctic continent. It has nothing to stop it. All the other currents are stopped by a continent. So it just zips right on around the Southern Ocean. And it is, of course, south of 60-degree latitude and is the 4th largest ocean. Again, the circulation does make quite a bit of difference to Antarctica, and the 2 different, you have the deep water formation and then a little bit more of the upper current in the red. You have a little picture in this diagram. Close to the ice shelf of Antarctica is the east-west drift, and right over here is the west drift. So get a little feel as to what it would be like right in that ocean. Once again, we'll see the break off. Going around and around and around, you can see the various currents around the ocean. The drop in temperature and an increase in density and salinity makes quite a bit of difference as to which direction it's going to go. Huge quantities of the water are going in a very, very fast current around this entire Antarctic. Again, you have counter currents and currents that go all the way around. Here's a little picture of the distance at which the currents are actually going. Mount Melbourne in North Victoria Land still has steam vents and fumarole activity along the summit. Mount Discovery has several volcanic domes on the north side of the mountain. Mount Harcourt and 3 shield volcanoes make up the Ayat Peninsula that extends into the Ross Sea. North of the Antarctic Peninsula, 3 chains of islands have active volcanoes. The South Sandwich Islands, the East Sea underwater, the Deception Islands with numerous activity events. And here is a picture of where they are. Here you have the Deception Islands at that point and the various other small mini volcanoes. Many major volcanoes are active or have been active in Antarctica, except many are under the ice. You don't see them, except for a few. The cones are well preserved along the transatlantic Antarctic mountains. Depression in the surface gave evidence of a recent volcanism that might again become alive. And here's the Trans-Antarctic mountain range, not very far from the Ross Island group. So they do detect the underwater volcanoes here also around the Antarctic, like the Arctic Ocean. And if you remember this possibility that at one time, 40 million years ago, South America was connected to Antarctica on that peninsula, and that's the one that still remains. It represents the extension of the Andes Mountains and the Antarctic Peninsula. They are the result of volcanic eruptions. 2,000 years ago, a powerful volcano erupted under the ice sheet and still may be active. It punched a hole in the ice sheet. A plume shot into the sky about 8 miles high. There is very thick slab of frozen fresh water there now present. If you can imagine, if you took all the way the ice of the Antarctica, this would be what you would see from land. Of course, the outline shows you how Antarctica really is today, but this would be the land if you took the ice away. Underneath the ice, you would see pictures like this. Here's a mountain range. Again, not showing where the ice was and where the problem would be if you took the ice away. Here's some idea as to how thick that ice is. You get all the way to the summit at this point is 4,000 meters, or about 1,300 feet. It is very thick at that particular point. And as you climb up the, what would be the ice gets thicker and thicker as you go from, of course, the sea on up into the summit. And eventually we'll get there. But the South Pole is on this point, not quite at the summit. The average thickness is 7,000 feet. The greatest measured thickness is actually 1,500 feet. So lots of ice. Now underneath is something called the Gamburtsev range, under ice images that look like the Alps. It's located in eastern Antarctica. Rivers and lakes found under the ice, covered by ice miles thick, does not appear to be volcanic, not the Gamburtsev range. Shows sedimentary rock. And here's a picture of those if you take the ice away. Take the ice away from it, and you would see that kind of mountain range. Mount Boris is a peak above the ice covering of that range. Again, the orographic precipitations are on the edge, but otherwise it's really a dry part of this area. Now, once again, we just go back for orientation. Where is this international date line? Well, if if you go to the South Pole, all right, go over on this side, you're in the west, on the other side, the east. So this is 0. Where's my, there we go. This is 0 longitude. McMurdo Station. That's what it looks like. Oh. Everybody has the right answer? Let's see if I've got the right answer for you. Okay. Are you ready? Number 1 is dog. Do I have the right sheet this time? Number 2 is jig. Number 3 is Mike. Number 4 is oboe. Number 5 is Charlie. Number 6 is Abel. Number 7 is King. Number 8 is Nan. Number 9 is Baker. Number 10 is Peter. Number 11 is George. Number 12 is Roger. Number 13 is Fox. Number 14 is Love. Number 15 is How. And the last one is 16 is Easy. Everybody got them all correct, right? At least you do now. Well, you can turn it over and what do you have? Yeah. Okay, go ahead. Yes.
Just a quick question. Are
Sure.
there earthquakes on Antarctic? Is the ring of fire, where does that pass near Antarctica?
Yeah, that's a good question. Yes, there's definitely earthquakes there. And of course, a lot of volcanic activity. I guess could include that because it's part of the Pacific Ring of Fire in many ways. I would say that it would be part of that because it's close enough to the edge of the Pacific, which really is basically in the Pacific, around the Pacific Ocean. The ring of what they call the Ring of Fire. Anyway. Lots of activity down underneath. And you don't escape that here in Antarctica either.
You don't hear very much about it in
No.
the news.
No, that's right. I don't know whether anything is particularly spectacular of recent times that would be newsworthy. Although the last couple have been in the last 10 years in the area of the Antarctic. So there's a lot of volcanoes that are active, as you can see in this one map. Yeah. Yeah. Thank you for that. Anybody else? Now we get to go ahead, Dennis.
The raising of the ocean due to the melting of that glacier. How confident are they in it? It seems to me
Yeah.
I've heard some comments that it's not going to raise the ocean, the reaction of ice to water and so on. You know, they do that sample in a glass of water with ice in it. I guess it doesn't change or something like that.
Oh, I see. Well, I'm not so sure that I'm not sure I would believe that particular argument because once it's melted, it definitely causes more water in the ocean. It's got to go someplace. So, yeah.
I just noticed the conflict.
Oh, yeah. Yeah. Well, okay. At least that would be my opinion. I don't know. Okay. We're going to get to the South Pole here eventually. Let's see once whether we can. The research center on the southern tip of Ross Island, okay, it is capable of supporting 1,200 residents. All personnel and cargo must pass through McMurdo on the way to the South Pole, which is known as the Amundsen Scott Station. That's what we'll be looking at. In 1841, the area was charted by McMurdo. And as a consequence, also Ross, and therefore left those two names right there on the edge of the Antarctic. US opened its first station here in 1956, not that long ago. A nuclear power plant was activated in 1962. They are always looking for some kind of power to keep warm. That's about it, basically. So this particular ship, Southern Cross, unloads its cargo, puts it on the ice because they can't get any closer to the other part of McMurdo, too far away from the pier. So an example of one of the icebreakers here, they like to deliver it, of course, obviously in the summer when they have less ice. I can understand that. Here, a Russian icebreaker is helping the ship reach McMurdo. And this happened to be a picture in 2006. Once again, here where we are, McMurdo, down at this point, and up here is the South Pole. Now let's see if we can make that distance. Well, here's another one of the research stations. The Princess Elizabeth Antarctica is a Belgian research station. It's one of the most recent ones. A pretty interesting kind of a building. And it has a number of chargers here to make some electricity. Its picture looks like this. It's located on the Utsanan Nanatuk in the Queen Maud Land. It's one of the more recent ones. Again, another picture of it. But notice how it's nicely built on big stilts. Almost has to be. Looks like it at night. Inside, not a bad place to work. Maybe, if it's warm enough. And if you didn't see where it was in the Queen Maud Land. Okay. The Signy Station was named by Peter Savell, a Norwegian whaler, after his wife, Signy Teresa. It is a research station to study biological marine life. Okay, we'll see why that's true here in a moment. It opened in March 1947, and 10 people live there year-round, with many more during the summer of the hemisphere summer. And notice where it's at. There, Signy's way up in that point. It's a long way from the South Pole. So they could live there year-round without too much difficulty. That's a whole lot different than being at the South Pole. There's another one, a research station here at Heli. And we'll look at Palmer in a moment, and Ruth is in that point. These are research stations of the various ones. Palmer happens to be one of the 3 US research stations. It is to research marine biology. Well, if you're out there on that island, I guess that would make sense. Palmer also is in that same area that I just pointed out, and so is Rothera. These are research stations for marine life. Again, take a look at where they are. The Palmer here in the Rothera, as well as up here, which we just said, Signy. Now, the Hilly British Research Station, which was on that island. They built the Simpson buildings 5 times Snow covered and crushed the first 4. The buildings 5 and 6 can be raised each year. So the British measured ozone depletion in 1985. So that was part of their mission to research. Well, maybe this is true. Recording scientific data for the past 3 minutes, all you have written here is froze my butt off. Yeah, I don't believe it. The South Pole froze over in the coldest winter on record. It's all been frozen a long time, but the coldest on record was in October 2021. The rest of the world had the 4th hottest summer in 2021. Now let's look at Christchurch. That is where the International Antarctic Center is, right at this point, New Zealand. And if you go to New Zealand, you can get into their center there, which shows everything they can about Antarctica. So this is actually in New Zealand, into that international Antarctic building. One of the rooms is extremely cold to give you a feel what it's like. I stepped into that room and it was too cold for me to last very long. And it didn't. I didn't have to prove that it was cold. It certainly was. Here we have a building. The original station back in 757 to 75, virtually buried with wooden roof collapsing. The new station was built in 75, and we'll find out that we have to build and build and build. It accommodated 4 feet of snow per year. This is the interesting one, this dome with this big door into the ice, because the snow piled up all around this dome after they built it. There's a person called Jerry Nielsen, and maybe you have heard of her. We'll find out whether you have or not. Maybe the story will become familiar to you. But she lived in this particular dome over the winter. And once you're down at the South Pole, you cannot leave. There's no way to get out of there. The airplanes that can, if they land, they can't get back out. So you're there, you're stuck. Inside the dome, they have their buildings. The buildings are inside the dome itself. And so inside of these are various offices and, well, dining areas, movie houses. But this floor down here is really ice because it's all built on the ice in this dome. It's in the dome. So if you are going to travel from one place to the other, well, you still need something on your feet in order to get to the next spot. It's not warm in there at all, only in the buildings themselves. Here's individual housing, and just another pictures of those units inside. Picture of people on their way to the South Pole. Okay, that's particular plane load. Life at the South Pole. Let's see what that's like. Antarctica is the coldest, windiest, and highest continent on the Earth. The dome contains the living area for 250 people. However, not all of those stay over the winter, their winter. In fact, when Jerry Nielsen was there, she stayed with, I think there were 61 people that stayed over. And once you're there at the beginning of the winter, you don't move. You're there. Well, she agreed to be a medical doctor for the entire unit over there, and took care of all the medical needs of the people that were there.
Right.
Maybe you've heard of this story. Let's see once whether you have or not. She was born in 52, died in 09. Besides the usual health issues of cuts, bruises, and illnesses, there is a constant monitoring of the amount of oxygen available for the human body. The air is thin at 9,000 feet above sea level. So that's a problem that they have to monitor all the time. Well, she's down there to help do that monitoring. In 98, Jerry Nielsen was hired to spend 1 year at the Edmondson Scott Station at the pole. During the Austral winter, she developed breast cancer. And maybe that might ring a bell with you. Well, she did some teleconferencing with medical personnel in the United States, usually out of Colorado. She had to operate on herself to extract tissue samples. Part of the reason because she couldn't get anybody else to do it for her. And one of the guys closest to her, known as Mr. Big, he was a very good friend of hers, but he couldn't stomach the idea of any kind of operation, evidently. So she had to do it herself. The first military plane airdropped the equipment and medication to the station. But here it shows a picture of how she is doing her own biopsy, which is, well, you have to, if you have to, I guess you have to. That's all there's to it. Not comfortable. Her office looked like something like this anyway. This, I think, is a little better one than what she was in. This is a little newer one, but they have a medical room in this South Pole area. And so the operation was made. Well, her condition was life-threatening. A plane loaded in early spring in adverse weather conditions to bring her and another person back to the United States. Earlier, they were able to fly over, even though they couldn't land, and drop things, medical supplies by parachute down over her particular area. Pitch dark out there, just absolutely pitch dark. This was the type of plane they used to go pick her up. But the actual plane, if you notice the skis along the bottom, and I'll show you the next picture too. But the skis, when they finally did land at the end of the winter season, supposedly their spring, it was still very dangerous and very cold. And so when they landed, the skis immediately froze on the ice. And they evidently detached them briefly and able for the plane somehow to rock and to loosen the skis up so they could take off. After they picked up Jerry Nelson and another person who also really needed to get back to medical care. So they finally made it. This is the picture that the city of Christchurch landed to pick up Jerry Nelson. After several surgeries, her cancer went into remission. She became a motivational speaker for hospitals around the country. Cancer returned in 2005, and with treatment again, went into remission. In October 2008, cancer returned in the form of brain cancer. So she continued to meet the speaker schedule to the very end, but in 2009, she died. That's Jerry Nelson. By the way, there's a book about her called Icebound, I believe, which might be very interesting to read all the details that she had to go through in order to live. Well, it had to be a fairly clear day in order to get this, and it was not nighttime or wintertime, I should say, to get this picture of the staff that was at the station. That's not necessarily the same group that was with Jerry Nielsen. The place where they could go into these Quonset plate huts, they could drive their huge machines inside and be able to get around in the outside, even if it was bad. This is a room of the generators. They had at least 3 generators to produce electricity, heat, and the like. These 3 diesel engines provided the power and the heat necessary, and they rotated them all the time. They were rotated every 8 hours. The waste heat from the generators is used to warm the building and water generation. All right, they had to get water someplace. Only 1 generator is on line at one time. And if you read the story on Jerry Nielsen, every once in a while, they would have very difficult time with maybe a generator would go out. And then they would really be frantic in order to get it started again if they needed all 3 of them. Well, the waste heat from the generators is used to warm the building and water generation. Okay. The water will leach minerals from the human body that they get there. They melt the ice. Even though the water is pure, it is corrosive, unhealthy to drink. Minerals are added by running it over limestone. Chlorine is added to purify it. The melted snow and ice is the best water, is from the ice at the Fern level, which is maybe 200 feet down. It is the old ice in terms of what we would say old ice anyway. The snow that's on top of it is more recent. Hot water is pumped down about 200 feet through the ice, and then the melted ice produces clean water and is pumped up to the surface. More hot water sent down continues to enlarge the reservoir at that level. Okay. Now, what do you do with the solid human waste? Yeah, you can't just toss it out on the ice. That doesn't work. It's usually pumped into these used water reservoirs. Gray water or urine or shower water is treated and recycled. Water conservation is used extensively. 1 load of wash is allowed per person per week. 22-minute showers per person per day, or 18 gallons. And let's compare that to the normal use in Madison, Wisconsin, where you use about 80 gallons per person per day. Is that what you used this morning? So can you get it all done in 18 gallons? Solid waste is recycled. This is one of the newer buildings that I'm picturing here to show where this recycling is going on. Inside, there are hydroponics, and they are growing fresh vegetables, at least some. It's mostly salads. And of course, they grow it without soil. But hydroponics allows them to at least have some greens, even in the dead of winter, which is rather important for the health of the people. But this goes on then all the time in order to keep greens in supply. An office in one of the red buildings might look like this. Well, this happens to be the dining area. And they would get together for movies and festivals and whatever, because 6 months is a long time, as you can imagine. So they would entertain each other with all kinds of things. And in a decent place to eat. And they had usually really good food. They could ship that in a frozen state, keep it And then all during winter, they ate plenty. They were in good shape in that score. This little guy, you could get around with it. Yeah, if you had to go outside, and many times they did. Yeah, they go outside to go into the other buildings. So you could get in here and travel around. They had other kind of snowmobile type of machines as well to get around the South Pole. Outside, you will find what they call this Sturgeon ice ridges. These ridges become very, well, they're straight, but they become very solid. And so you need a big tractor in order to get across these. The Sturgeon snow crystals turn into pellets. Again, and this is a picture back in 2016. That building and the dome nearby. Eventually, they tear down the old dome that Jerry Nielsen was in. Eight 118 below zero. Again, a nice picture of the whole complex about 19. This is 2016. The South Pole Station is built on stilts. Why? Because every so many years they have to rebuild the whole business. It gets buried. Take a look at the new one. The latest one anyway is of this color. The new station looks a little bit in a closer form here. You could take a good look at how high it is on the stilts. Well, what's ever inside, of course, is pretty, well, they're pretty comfortable once they get it all put together. But look what happens to the building. And this is a drawing of that kind of thing. And notice that once you've got a building up, okay, underneath it, the wind will blow the snow underneath it. And the ice pack itself continues to move. Inside, you might have a building with this, in this drawing, with their offices and communication back and forth. So this is where that group of people would work and live inside of that. The real problem, in order to get stuff over there, it may start out here, wherever, whether it's in the United States or in, actually, a lot of it gets into Christchurch in New Zealand. Put it on a ship and gets it over to McMurdo, and eventually the airplane may drop it over to South Pole. That's the kind of route that they take in order to keep the place going with supplies. And obviously, it can have some beautiful scenes with the Aurora Australis. Again, a big, better picture of the station. They have some out areas here, and that's why they need that big piston bully in order to get it into the other areas to get supplies and whatever. And they're always afraid that, be careful for fire. Once you have fire in something like this, you're in big trouble. So that's why some of the buildings are separate from all the others, to make sure that any hazardous or fire material are stored elsewhere. Okay, you got a little picture there of that station. Notice the flags that they put into the ice so they don't get lost when they go to the other station, because you got to realize that this picture is in the summertime, or they have light, but in the wintertime, that is absolutely pitch dark. You don't see anything except stars. I guess, the beautiful stars formations. The North Pole or South Pole. This is supposed to be the South Pole. All right. How did they get this figured out? Well, because it moves. The ice moves. But each year they put up a new marker. This is one of the geodesic markers. This happens to be the USGS marker at the South Pole. And it usually has something on this, or they change it every year. This one happens to show a midwinter season and the summer season down here. Every January, the marker position is redetermined. See, it's summertime down there because the glacier moves 30 feet per year. So they have to reposition the marker. This happens to be the 2006, and notice it does represent more of the modern building. Here's the 208, 209 marker, 2016 marker. And here's 2021 marker. Put it out there. The pole moves west 32 feet per year. Okay, now let's go to another particular spot on the ice. Notice there is a spot at this point. It's called the Vostok Antarctica one. And obviously this is what country? What would Vostok be? Russia. It's got to be Russia. Okay. So let's take a look at it. The world's record minus has been held here, 128 degrees. Vostok is not at the center of the South Pole, but is just off a ways. What did the German or the Russians do here? Well, they drilled a hole here. And in that particular hole, they discovered way down underneath a lake. And so they named it Lake Vostok. So this is a lake under the ice, at least 1.5 miles or more under the ice. But while they're there, at least on the edge, they did build a Orthodox church for the Russians. But let's go back to their Vostok place. At this point, near the southern magnetic pole. All right. Let's see where that is. Vostok. It's out here on the edge. What they did, they have this nice big tall outfit here, which acts as a drilling machine. So they drilled through the ice and all the way down. And then, of course, when they did that, they found that there was fresh water down underneath in the lake. So the Aurora and Wilkes subglacier basin is as big as half of the United States. So it's way down underneath. Subglacial basin. Lake Vostok is more than 2 miles under the ice. So how you get down there? We drill. So they have found 145 other lakes trapped under the ice. Quite a few. Okay. Interesting that they could drill down in that particular way. Vostok Science Research Station is very busy in that drilling. Let's take a look at it a little bit more. That is the drilling tower. And they come up with these cores. If you take a look at the cores, these are ice cores, as they gave one on. They studied the ice cores all the way down to the lake, to the fresh water. It's rather interesting that they've tried to find maybe old very ancient water life of some sort, if they could find anything that they thought maybe they find prehistoric kinds of some kind of animals or germs or whatever they could find, bacteria. But in so doing, they didn't do too well because every time they drilled down there, the very drilling contaminates the species that they pull up because they have to melt it in order to get down to that point. Down to Lake Vostok, 2.25 miles below the surface. Like I say, there are many other evidently lakes underneath. This is what it would look like if you got rid of all the ice above. Supersaturated oxygen about 50 times greater than the typical freshwater lakes. This lake has tides, actually has tides, but okay, it only raises and lowers about 1 to 2 centimeters, but it's got a little bit of a tide. The moon must influence it. The lake is divided by a ridge. One basin is 1,000 feet deep, while the other is 2,600 feet deep. Underneath the ice, a long way down. It's amazing. They use this particular instrument to sample the water that's underneath, if they can pick it up at all anyway. Lake Vostok, size similar to our own Lake Ontario. The Russians and the British are sending a cryobot through the ice with a hydrobout that can maneuver in the fresh water to view possible life. Again, look at what the possible underwater lake, under ice lakes look like, and the patterns of streams and the like underneath the ice. Besides Lake Vostok, there are 2 other large lakes with names. Lake 90° east is second largest. Lake Sovetskaya is third largest. If the Russians gave them names, I guess we have to learn how to pronounce them. What do you think? Yeah. Well, Mom, someone left the penguin cage open again. Okay. Yeah. The test today. See what this gal is telling the teacher is saying, turn off your cell phones and your GPS. Otherwise, you can't take the test. Oh, here, maybe this is germane today. If it's any consolation, the teacher says, I have a bright future in realigning college athletic conferences. There you go. So everybody's got their own total good answers, right? Let's see if I can read these for you. You can't see them from there. Number 1 was Charlie. Number 2 is Jig. Number 3 was Fox. Number 4 is King. Number 5 is Oboe. 6 is Mike. 7 is Baker. 8 is Nan. 9 is Love. 10 is Abel. 11 is George. 12 is Dog. 13 is How. And the last one, 14, is Easy. Now, anybody want to tell a story about their experiences on Antarctica? I take it none of you have been there, although that's not impossible. We have people that once in a while have been to the place. And how many are planning to go? And make sure you have your long johns. Yeah. Any questions or comments that you want to make? Okay. Well, Susan, I think I'm finished. You got any from your,
Well, Jerry, thank you very much for your very helpful presentations on the polar regions. They've been great, and we look forward to having you back again soon. Thank you.
well, thank you for
You're here.
listening. All of you. Thank you very much.
Thank you, Jerry. Thank you to everybody at home and have a great day. I'm going to go ahead and close the class.